Hey guys, in this unit we're going to be looking at classifying matter, that is, putting it into groups based on how it acts. And we're going to start with two groups called compounds and elements. But in order to do this, in order to talk about any of this, we have to have a very good understanding of atoms and where this idea of atoms comes from. So before we get too much into these classification schemes, let's talk about how we know these atoms exist in the first place, because we need to settle that right now. And the guy who really offered proof that atoms exist is this man, John Dalton. John Dalton, in the early 1800s, was conducting experiments on vapor pressure in gases and in the masses of compounds that have been broken down. And just to give you a quick rundown on this, there were two types of substances that we for sure knew about at this time. We knew there were elements, stuff that you couldn't break down anymore, and then compounds, which you could break down. So John Dalton was breaking these down, studying the vapor pressure of various volatile liquids. This just means how much gas pressure builds up over the top of that liquid. And in doing so, he stumbled upon proof that atoms exist. Now, some other things to note about John Dalton. You'll see in a lot of textbooks that he was a school teacher, and the reason for this is that school teachers write textbooks, and John Dalton, as a teacher and an incredible scientist, is kind of like a hero to us. Now, that being said, teaching was basically just how he paid the bills. His heart was really in science, and rightfully so. He was a fantastic scientist. In addition to proving that atoms exist, which is kind of a big deal in and of itself, he also discovered color blindness, which is sometimes called Daltonism. But let's get back to atoms, and let's talk about some of the experiments, particularly with breaking down compounds that John Dalton performed. So here's what we mean by breaking down compounds. Water is a compound, and when you break it down, that is, when you create simpler substances from the water, you get these two things, hydrogen and oxygen, that form from it. So again, you can start with water and through various processes end up with just hydrogen and oxygen and no more water. Water is a compound. You can break it down into more simple things, hydrogen and oxygen. Hydrogen and oxygen themselves cannot be broken down into anything more simple. They stay the way they are. Now, people had that idea. Dalton took it a step further by looking at the masses of these. So suppose we started with 18 grams of water. If we were to break down 18 grams of water, we would end up with 2 grams of hydrogen and 16 grams of oxygen. By itself, this is fairly unremarkable. John Dalton took a brilliant step with this, though, because he looked at these two numbers and he noticed something as he broke down different masses of substances. So for instance, with 18 grams of water, you end up with 2 grams of hydrogen and 6 grams of oxygen. What I want you to do in your head is take the mass of the oxygen and divide it by the mass of the hydrogen. 16 divided by 2 gives you 8. So there's 18 times as much mass of oxygen as there is, or not 18, but rather 8 times the mass of oxygen from hydrogen. Because again, 16 divided by 2 is 8. Now let's break down a different amount of water. Let's say we break down 100 grams. So instead of 2 grams of hydrogen, we end up with 11.11 grams. And instead of 16 grams of oxygen, we end up with 88.89 or 88 grams of oxygen. So now check this out. If we take the mass of the oxygen, 88.88, divide by the mass of the hydrogen, we get the same number, 8. And it doesn't matter how much water you break down. You can pick any mass of water. When you break it down, you always end up with 8 times as much oxygen as hydrogen by mass. And after noticing that this worked for certain compounds, Dalton tested it for others. And every compound that he could break down always ended up with the same ratio. Ratio is just a fancy way of saying the number you get when you divide one by the other. He ended up with the same ratio of elements out of these compounds. And so this was called the law of definite proportions. Now, this was hinted at before Dalton. Dalton is the one who really put some concrete proof to it, recorded his numbers, showed everything. And Dalton made the extraordinary leap of realizing that this could only be true if that water was made of atoms. There were little tiny parts that could never be broken apart, and these little tiny parts were combining in specific ways to form the water. So you would have hydrogen atoms and oxygen atoms that would come together to form water. And again, this was called the law of definite proportions, the fact that the ratio of the masses was always the same. And from this, Dalton developed his atomic theory. And atomic theory is just a way of saying it's his theory about atoms. So here was his atomic theory. All elements are composed of atoms. So remember, elements are the ones that can't be broken down. So hydrogen, oxygen, nitrogen, all of that is composed of atoms. Atoms of the same element have the same mass. So every hydrogen atom would have exactly the same mass. All hydrogen atoms weigh the same. And atoms of different elements have different masses. So oxygen has more mass than hydrogen. Compounds contain atoms of more than one element. So for instance, water is a combination of the elements hydrogen and oxygen. And in a particular compound, atoms of different elements always combine in the same way. So a good way of looking at this is that you always have in water that same ratio of hydrogen to oxygen atoms. If you have a different substance, hydrogen peroxide, say, you have a different mixture of those two. Hydrogen peroxide is still just hydrogen and oxygen, but instead of 2 hydrogens for every 1 oxygen, now it's 2 hydrogens for 2 oxygens. And this was Dalton's atomic theory. And notice that he wasn't right about everything on this, but that's okay, because this was the first time somebody had laid out this particular model of how the universe works, basically. This was an idea of how all matter was put together. And even though parts of it were wrong, big chunks of it were right. And this is how science happens. Somebody offers proof, as John Dalton did, that atoms exist, and then later on we go through and we refine it. We find the things that are good and we keep them, and we get rid of the things that were inaccurate and replace them with more accurate statements. So, things to take away from this, and if you want to go back through and find these, I highly recommend it. You need to know that John Dalton was the man who first offered proof that atoms exist, and that proof came in the form of the law of definite proportions, which says that when you break down a compound, you get the same ratio of mass of the components that make up the compound. You also very much need to know John Dalton's atomic theory, know all those points, really commit those to memory. And also, know a little bit about this, is that atoms had been suggested before John Dalton. In fact, about 2,200 years, that's 2,200 years before John Dalton, a Greek philosopher named Democritus had much the same theory, that all matter was made of these little tiny atoms. However, Democritus didn't have proof. John Dalton did. And that's the difference in science, is that we rely on proof for things. And frankly, that's one of the most beautiful ideas that human beings have ever come up with. So again, John Dalton proved atoms exist using the law of definite proportions, came up with the atomic theory that you see before you, and he had proof, most important of all.